Let's do another example. A vehicle with a mass of 8 tonnes and a wheelbase of 4 metres. The centre of gravity is 2.5 metres behind the front axle. I want you to determine the load in kilograms on the front and rear axles. And also, if a box with a mass of 350 kilograms was put 750 millimetres from the rear axle, what would be the new loads on the axles? Well, how do we determine this? Well, first let's draw the problem. As you can see there, we can solve this by taking moments about a point. Now the total load is 8,000 kilograms. That's what we know, 8,000 kilograms. Let's take the moments from the front axle. Well, from the front axle, 2.5 times 8,000 equals 4 times R, the rear axle. Therefore, 20,000 equals 4 times R. Therefore, the load on the rear axle is 5,000 kilograms. And therefore, the load on the front axle must be 3,000 kilograms. So that's what we know now. That's what we know. Let's just check this by taking moments around the centre of gravity. They must be equal or the force won't be stable. Must be equal. Therefore, F times 2.5, the front axle, equals R times 1.5. Therefore, put them into numbers there, 3,000 times 2.5 equals 5,000 times 1. It comes out 7,500. You understand? They're equal. So that just proves it, by taking a moment somewhere else, it proves it's actually valid. Let's determine part B now. When a box weighing 350 kilograms is put 650 millimetres from the rear axle, what is the new weight on each axle? Now, how do we tackle this? That's the key thing. Now, how do we tackle this? Well, here's the drawing here. Draw what you've just seen. Draw what you've said. And we know the total load now equals 8,350 kilograms. So we know what the total mass is, 8,350 kilograms. Let's now take the moments about a point. Yeah, take that point. Let's take the moments from the front axle. From the front axle, 2.5 times 8,000 plus 3.25 times 350 equals 4 times the rear axle. Do you understand? Take a moment round there. Therefore, 21,137.5 equals 4 times R. Therefore, the load on the rear axle is 5,284.375 kilograms. And therefore, the load on the front axle is what's left, is 3,065.625 kilograms. Do you see how you work that out? You take a moment on any of those points, and if you did that with a different moment, it would come out the same. This is how you work out moments and forces. Now, what can happen if you get it wrong? Well, this is what can happen again. This crane here has been brought in to lift out of a car in the water. Can you see that? The problem is the crane driver forgets about the moments and the force according to the distance from the fulcrum. So when he tips it out there, as you can see what happens, the actual crane goes in. That's what happens. And then what do they have to do? Bring a bigger crane in, because this is about the moments and how far away the lever is. If the lever's far out, there's a lot more force on it, and that's why it tippled over into there. That's just showing you what can go wrong.